So the chemical properties of elements are periodic because the number of valence electrons is periodic. And that is because of the structure of these different subshells. We observe that elements in the same column have similar chemical and physical properties, and that elements in a period show a pattern that repeats. This is because of the number of valence electrons and the kinds of orbitals that they occupy. Those are also periodic. So if we look at the noble gases, group 8A, except for helium, all of these noble gases have 8 valence electrons. Their electron configurations are whatever the period is, S2 and P6, so 8 valence electrons. The noble gases are practically non-reactive. They just do not react much at all because they are already very, very stable. We'll learn later that atoms react and form bonds or ions with other atoms to become more stable, to have a lowered energy. I think of these noble gases as being a bit like that in-crowd of kids in high school. You know, the guys and the girls, you know, maybe it was the football players and the cheerleaders, and they went to all the good parties, and they just seemed to have all the fun that the rest of, well, I was in the rest of us. I don't know, maybe you guys were cool, I wasn't. You know, we just kind of looked on and like, oh. And some people really try to get into that group, and they often do so by dressing like the cool kids. So you guys are all out of high school now, and the older you get, the more you'll look at these high school kids, you know, like, wow, that's just really strange. You know, I'm trying to express my originality, they say. I'm trying to be my own person by dressing like everyone else in the school. It's funny. It's really funny. I've seen it with my kids. So I think of electrons as being like the clothing that an atom wears because it's on the outside. And so we'll see that this 8 electrons is a very popular type of clothing for atoms. They want to have 8 valence electrons. Of course, it's not because it's cool or anything. It's lower in energy, but that's not so fun to talk about. The alkali metals are group 1A. So these guys each have 1 extra electron compared to a noble gas. They've got 1 extra electron. So they can get a noble gas configuration quite easily by just losing an electron. This is like, you know, mom made you wear that dorky hat to school because she thought it was going to be cold. And what do you do as soon as you get there? Take the hat off, right? Ditch the hat. So these guys are very ready to ditch that 1 electron. Because if sodium loses this 1 electron, then it has 10 electrons, the same number of electrons as neon. Does sodium become neon? No. But on the outside, its electrons look like neon. When you dress like the cool kids, that doesn't make you one of them. You just look like them, right? So the alkali metals form +1 ions. And we learned to predict that before by saying, well, group 1 metals form +1 ions. Quantum mechanics explains why. The halogens are on the other side of the noble gases, group 7. So fluorine is just 1 electron short of 10 electrons, 8 valence electrons. Neon is right next to it. If it could gain an electron, pick up an electron from somewhere, its outfit would be complete, right? It would have 8 valence electrons. So fluorine reacts in a way where that happens. It will gain 1 electron and become a -1 ion. All the halogens do that. They tend to gain 1 electron, forming a -1 anion. And they do that because having 8 valence electrons is lower in energy, it's more stable. So electron configuration is related to ion charge. I kind of previewed this, but group 1A plus 1 ions, group 2A plus 2 ions, group 7A minus 1 ions, group 6A minus 2 ions. We saw group 5A did minus 3 ions. They do that because when they gain or lose the electrons required to become that ion, then they have 8 valence electrons, the same electron configuration as the noble gas. They don't become the noble gas because the number of protons is different. The protons is like the inner, like your soul, like your personality. You can't change who you are, but you can change what you look like. So atoms can change the electrons on the outside. They're still the original element that they were. So if we look at this periodic table, just be aware that the one in your book, they numbered the periods wrong. So these guys all form -1 ions because by gaining 1 electron, they'll have an electron configuration the same as the noble gases. These guys need to gain 2 electrons to become like a noble gas. Nitrogen needs to gain 3 electrons. Let's not go that way, let's go back this way. So lithium, sodium, all of these guys, if they lose 1 electron, they're jumping around back to this. Really, the periodic table should be a cylinder. Just like maps of the Earth isn't flat. The map should be round, right? It's not practical. So it's not practical to have the periodic table in a cylinder, but that's really what it's like. And so you can think of this as being connected to this one over here. It's really just a big spiral. Sodium loses an electron. It becomes like neon in that it has the same number of electrons. Magnesium needs to lose 2 electrons. 1, 2. Okay? Here's aluminum. Aluminum needs to lose 3 electrons. Okay, what about these guys in group 4A? How could they get a noble gas electron configuration?
They can go either way.
They could go either way, but either way it's 4 electrons, right? It's a long way. So those guys are just so dorky, they decide to just be okay with it and they don't even try. Carbon really does not form -4 or +4 ions. It's too much work. It just stays carbon. So that's why we haven't talked about any ions of carbon or silicon. Now when you get down here, those are metals and then things get a little different. Any questions? Well, we can write electron configurations for ions also. Let's talk about anions. So anions form when nonmetals gain enough electrons to have 8 valence electrons. In that situation, the S and P orbitals of the valence shell are full, and that's more stable. So if we look at sulfur, here's the electron configuration for sulfur. It ends with 3s2, 3p4. So it's got 6 valence electrons. It wants to have 8, so it needs to gain 2 electrons. So we put a 2- charge on it, and those 2 electrons go into this 3p to fill it up, 3p6. This electron configuration is the same as argon. It's the same number of electrons, but it's a sulfide anion. It's got a -2 charge, and it's got a different number of protons than argon. Let's look at cations. Cations are formed when something loses electrons. So for those main group elements, the metal atom loses all of its valence electrons, and under the valence electrons is a full shell. So it's like peeling away this partial onion skin, and underneath is this full, beautiful onion skin. Onion, the layer of the onion. Always makes me think of Shrek and a donkey. Life is like an onion. So magnesium, here's its electron configuration. 1s2, 2s2, 2p6, 3s2. So by losing 2 electrons, these 2 electrons, it gets a noble gas electron configuration, the same electron configuration as neon, the same number of electrons as neon. And so that's more stable. Magnesium then has a +2 charge on it because it lost 2 electrons. Any questions?